Hello there, everyone. My name is James Vancini. I'm one of the original founders of Netreo. And today we're going to be discussing what you should and should not be managing from the cloud. We're also going to be looking at different cloud-based monitoring architectures and discussing how to choose the correct one for your particular environment, as well as how to best automate your cloud monitoring. So hopefully these will apply to your environment regardless of whether you're managing devices that are entirely local, entirely cloud-based, or like most companies today, somewhere in between. So let's take a look at where we're at with the cloud today. The vast majority of enterprises already have a cloud strategy, and most of them are well into implementing it. 81% of organizations use multiple clouds, and that can help avoid vendor lock-in and can provide redundancy. But it also adds complexity, and smaller organizations might be better served with a single cloud strategy. So we'll talk a little bit about that today as well. We've reached the point where the majority of organizations are using a hybrid cloud approach with some resources off-premise and some on-premise. So all these different environments deal with what's the best way to implement our monitoring to leverage it. So let's look at some of the models that we could use. So in the traditional on-premise model, most of the performance data is collected by interrogating the devices directly. So this is the model we're all familiar with. However, in a hybrid cloud environment, this means data that has to be collected directly from the cloud-hosted devices as well, which might not be ideal from a security, configuration, or bandwidth perspective if we have a large number of cloud-hosted systems. And in this model, all of the data is housed in the central monitoring system, including all of the collection, storage, reporting, analysis, and the user interface is all provided locally. So the opposite model is also possible. So a fully cloud-hosted model, we have the opposite effect. Data from the local enterprise has to be collected from within the cloud. So depending on where the majority of your monitored resources are, this might make more sense than keeping the collection local, but most customers that we see today aren't deployed mostly in the cloud. Collecting on-premise data from the cloud has some serious implications when it comes to your firewall architecture if you don't have a secure VPN to all your cloud resources. However, one big advantage of this model is that if you have remote IT workers or you rely on outsourced NOC services, they can get to the management system from anywhere they have internet access from, even if your corporate locations are offline. So in this model, the data UI and collection functions are now located solely in the cloud. With a hybrid model, we can kind of split the difference. So we can collect the cloud data from within the cloud using a remote collector and then pass that data back to the central monitoring system via an encrypted API for analysis and collection. So this allows us to overcome some of the bandwidth or security issues that we might otherwise deal with while keeping our data and our access to that data on premise. Local devices are still monitored and pulled from the on-premise system, which limits the bandwidth required and keeps the traffic local as much as possible. And we can use as many different remote pollers as needed to cover multiple cloud providers or locations if that's our architecture. So in this architecture, all the alerts, reports, and UI are kept on premise, and that remote poller does all the data collection. And if the connection to that remote poller is temporarily lost, it'll cache some of that data to be able to send back to the primary system once the connection is restored, so we're not losing visibility. There's also what we call the cloud-hosted primary, and this is really the model that most SaaS users have. And this is really the exact opposite of the previous model. So essentially, there's a collector device or an agent on premise that does all the data collection from the local devices, but the bulk of the storage and the UI is all handled in the cloud. Of course, the cloud resources are monitored directly from the cloud as well. So there is some collection done there, and there could be multiple collector devices in different locations or different VPCs around the world, or even in different clouds. So we can still consolidate all of our management into a single cloud. Now that cloud hosted system can be one that we ourselves host in a cloud provider, or it can be one that the vendor is hosting in a kind of shared resource environment, which is more typical of how SaaS works. So one of the keys to figuring this out is which of these models makes the most sense. So there's a lot of possible options here, and we have to think about a few different things in our environment before we can make the best decision here. So the first one is where we want the data stored. Cloud storage of data has the potential to be more redundant than an in-house data center, but it carries security risks that cannot be mitigated completely. So if your data is very sensitive, you may need to make sure it's kept on premise, and using remote pollers in various cloud providers or data center can offer you this. You may have regulatory requirements that force you to keep the data under your control as well. The next question is, where are the users who are interacting with the application located? So if the team is largely or entirely in-house, hosting the UI in the cloud may not be the optimal way to do it, because not only will it be fighting with other internet applications for bandwidth and access, but it might leave you blind in the event of an internet failure. And finally, monitor from where the users are. So when we say this, what we're really talking about is how are we monitoring our application performance? But it could also be the case that your IT team is remote, in which case cloud hosting the UI might be the highest performance option, especially if that's where the majority of the devices are located. So let's dig a little deeper into some of the other considerations that we want to look at as well. To really get all this under control, we need to start with process. So we need to adapt our action plan so that our platform hosted applications are included in how we're thinking about monitoring and alerting. For example, if I move my email to Office 365, I need to make sure that my escalation times match the service level agreements that I'm getting from my Office 365 vendor. I also need to make sure that we have a clearly defined process for how to deal with issues surrounding that application, such as technical resources who are trained in the use of the Office 365 admin console, and they have the correct phone contract numbers to be able to do vendor escalation in the event of a critical problem. You should also try to make sure that you have intelligent telemetry built into the applications themselves where that's possible. So not all container platforms or fast providers have complete metrics, and none of them can see into your application internals. For example, a simple API that can check the status of the business logic or provide a useful metric like the number of logged in users or the number of successful and failed transactions in the last 5 minutes can make creating these long-term metrics and reporting much easier. So if we can get to it during the development process when we're using an in-house built application, that always gives us a huge advantage. Now, especially if you're using multiple cloud providers, there's undeniably some added complexity that's introduced by monitoring. So some access control systems, like the one AWS uses, for example, can be very complex to set up, but can give you extremely fine-grained control once that's done. We can also use things like a VPN or a virtual private cloud to make this process much easier. So if we've already got one set up for other business purposes, that's ideal, but it allows the monitoring traffic to piggyback on your already encrypted secure configuration with very little added work. And then you can decide if the volume of monitoring traffic justifies a remote collector or if it's better done from a single central monitoring system. Remember that if you opt for a fully on-premise solution, you're still going to need to enable access to your cloud-hosted resources. So if this can't be done across a VPN, you need to make sure you're using encrypted methods to collect that data, such as SNMP v3 or TLS encrypted APIs, to make sure that things are still secure once they leave your infrastructure. And ideally, you want to restrict access to those APIs to only the monitoring system to improve security. Another thing we should think about when we're trying to decide what model to use is that we need to keep high bandwidth monitors like event logging and traffic analysis or NetFlow as close to possible to where they originate. So our platform uses specialized remote traffic collector and log collector appliances that can be distributed to help this problem. And if you have large data centers, this may even apply to on-premise deployments to help ease the load on the network. In a high density environment, we also might want to also distribute data collection, because when we're monitoring servers, we're doing it at the per process level. So we're monitoring CPU per process, memory per process, number of processes, which processes are running, and that can create a lot of bandwidth to and from those servers in a server intensive environment. So we want to consider that a potentially high bandwidth application. If we've got dozens or hundreds of servers that are cloud hosted, we're going to be sucking a lot of data across in order to interact with those APIs. One of the big advantages of keeping all of the data storage and reporting on-premise is the way that it allows you to keep complete control of the infrastructure and your costs. Usage-based pricing can really get expensive over the long term, even if you prepay it. So you have to weigh that against the need to periodically refresh hardware and platforms. But the equation isn't always that straightforward. However, you'll always know exactly what your costs are, which makes budgeting easier if it's on site. It also gives you the security of knowing that your data is entirely in your own hands. Now, while most companies are constantly working to improve and secure their infrastructure, hosting that on-premise means that the monitoring data and the sensitive credentials that are built into that benefit from those security efforts as well. And again, there might be regulatory requirements that mandate that you keep the data local, or be able to audit everyone who's got their hands on it or who's seen it, and that may drive the requirement for local storage. Another thing to consider is that on-premise hosting means your local team doesn't lose visibility even if the internet goes down or there's a DDoS attack or a cloud provider fails, which is very rare, but it does happen. On the other hand, hosting the solution in the cloud has its advantages as well. It means you're completely free of the admin burden of hardware maintenance and provisioning. So while our solution is delivered as an appliance, which means you don't have most of the overhead associated with server-based solutions. It can still mean a lower capital outlay than buying virtualization resources or hardware appliances. And of course, hardware failures are usually handled completely transparently in the cloud. It also enables easier access from anywhere. As we mentioned before, if the IT team works remotely or is even based remotely, this might be a big factor in your decision. Even if your entire headquarters network goes down, your cloud resources are still being monitored seamlessly, and the team still has access to the management platform, is still getting all of the alerts, reports, and visibility that they need to try to resolve those problems quickly. And of course, cloud providers often have a level of redundancy and availability that it's not cost effective to try to maintain in a private data center. However, when you're looking at hosting multiple systems in the cloud and you want to put your monitoring system or a remote collector there, you need to understand that just because the cloud provider says you're in the same data center, that doesn't always mean you're as close as you think. Sometimes providers will have multiple redundancy zones within a data center location, but in the real world, those can be many miles apart. Ideally, there's enough bandwidth and a low enough latency between those locations that you'll never see an issue, but it's something to consider and maybe even test or measure a little bit before finalizing the cloud architecture. Ultimately, this really just comes down to being sure that you're monitoring the hosted resources from the right location. So take careful measurements if you decide to move resources around in the cloud, especially if it's between providers. Cloud providers historically have made it not very easy to move your data between providers. It's their way of creating vendor lock-in. But that restriction can also mean that different cloud providers have different types of visibility that they may offer you. You may get better statistics from one cloud provider than another, and that might make it more appropriate for your workloads. These are just all things that you need to consider, especially if you're spreading across multiple clouds. So our solution integrates a network of remote reflector systems that allow the Netreo appliance to monitor public-facing websites from all around the world, even if your appliance is located on premise or if it's located in a specific remote cloud location. You can use this network to monitor from, Europe, Asia, Australia, all around the world to get real metrics for what's happening from where the users are located. We can use our network of these for public-facing applications, or you can deploy your own collectors for private cloud monitoring. You can also implement our platform fully in the cloud, which will allow you to get access from anywhere, or to deploy remote collectors in as many clouds as you like while keeping all of the data storage on premise. And this gives you the ability to get deep visibility into the application performance, no matter where the application is being run from and the end user is located, but also to isolate problems that might be specific to a particular section of the network topology or a particular remote location having a problem. You can see that differentiated from problems that are also being experienced by local users. And as the infrastructure gets more spread out and the users get more spread out, and we're putting our servers in more and more different locations, being able to measure the objective performance of a user from different locations becomes very important. One of the other things to consider is that although public clouds can be a low-cost option, the price can jump very quickly with heavy usage. So if we're using a dynamic cloud that scales on demand, we get a lot of the advantages of that, but we may be paying for those resources. So we need to keep a close eye on how many resources are being consumed in those clouds. So on the flip side, the cost of setting up a private cloud might even exceed the cost of a public cloud. So it's not exactly an easy calculation to make, and you may need to do some testing in your environment to really see what's going on. You want to keep a close eye on the resource usage and the billing. Most cloud providers have an option to alert when billing crosses a specific threshold or to prepay for a fixed amount of usage. One thing to consider is that monitoring systems like our platform are active 24/7. So hosting our system on a usage-based billing system might not be ideal if you can't prepay for that 24/7 usage. But you also have the option to use a provider hosted system that doesn't use usage-based billing. It's also important then to automate the reporting so we can get reports on how our billing is progressing and how we're getting how we're getting charged for the various resources that we're using in the cloud, whether that be storage or CPU or processing capability, memory, et cetera. And most cloud providers have a way to do some of this reporting and send that to you automatically. But it's another important criteria when you're selecting who your cloud providers are going to be, is to check into what kind of reporting that they offer for that. Now, regardless of which one of these models that you choose, one of the keys to making it successful is automation. So automating the monitoring lets us make sure that the monitoring system stays up to date even when we're deploying resources dynamically across multiple clouds. So our approach is to use web-based APIs that allow you to link provisioning processes directly into monitoring, or to automatically discover resources via APIs and then drive that configuration forward using rules to define things like categories, business workflows, templates that control all the different aspects of monitoring configuration without manual intervention. So we can auto discover cloud resources as they're brought online by interacting with the vendor APIs, or by having the vendors, script communications to us through systems like Puppet or Chef or Kubernetes or similar products, where you may be deploying containers and you can poke the monitoring system to tell it that you've done that, or we can interact with the APIs from the vendors to discover that as time goes on. The key here is that the less time we spend putting new systems into monitoring or taking them back out again means more time to focus on business success and actually achieving the goals of our organization. One of the keys here is to use a automated system to apply these attributes. So our approach is something we call auto configuration parameters. And auto configuration, it comes with a set of rules to help you get started, and you can easily customize or create new rules to fit your environment. So you can use these to do things like set device attributes like category, site, business workflows based on any device criteria, including things like what processes are running, what ports are open, what the device is named, where it's located, what subnet it's on. And this makes sure that there's no manual provisioning process to make sure that devices end up in all the right reports, and they always get the right settings and thresholds and alerts applied to them. These can automatically be applied to devices as they're discovered, regardless of what method is used to add them in or what platform they're running on. And you can also reapply these rules whenever you like. So if you want to make sure everything stays locked into those configuration rules, you can enforce that. Those rules in turn drive templates. And so using those configuration criteria that we've set with the auto config engine, we then dynamically apply all of the relevant templates to the devices. So this guarantees that all the settings we need are pre-applied as the device is added without manual intervention. For example, a SQL Server comes online. We want to make sure that it gets not only the basic Windows settings that I want, but also SQL specific application checks and settings, and make sure that the SQL team gets alerted whenever there's a problem with it. So I can detect that there's a SQL process running on the system and apply all those extra rules based on the fact that I found that running process, or based on the fact that the server is named database something. You can also use these templates to define things like authentication, escalation, and even automation actions like active response running scripts against systems. So it's designed to be flexible enough to really meet the needs of a large enterprise customer, but be simple enough to implement that a small IT department can do it without a lot of training or any dedicated personnel. One of the key technologies we use to simplify monitoring is anomaly detection. So we're constantly logging performance telemetry on all of the different devices and applications, including metrics like number of log messages received, CPU and memory use of each process running. Then we can go in and generate a baseline behavior model using historical data we retain. And for most statistics, that's 100 days of high resolution data. And then we can automatically adapt the baseline as the environment changes and evolves. So we can compare what's happening right now with what's normal for this time of day, this day of week, or even hour by hour. And you can set the sensitivity of the detection to high, medium, or low, depending on the tolerances and environment and what the usual range of that statistic is, so we can fine tune this process. That information is then used to detect when something unusual is happening, and we can flag that as an anomaly that can generate alerts or show up in reports. So this allows us to find things that we might not have expected. For example, one customer of ours discovered an issue because normally at 10 a.m. on a Wednesday, the database server was running at 50 or 60% CPU. On this particular Wednesday, it was running at 15%. It turns out that a minor fix that got pushed to production had a development API key in it instead of a production key, and it broke a process deep within the application where the front end team didn't notice it. As a result, the customers weren't able to complete the orders properly. And a change like that, a sudden drop in CPU usage, is the kind of unusual behavior that would never trigger a static threshold, but in this case, revealed a problem long before they noticed the drop in orders and the lost customers that would have resulted from it. You can also do things like tracking log messages for a specific problem. So for example, looking at the number of transaction failure messages or login failures might be very informative if the number of failures per hour suddenly jumps from 3 to 100. It gives us a place to look for what's causing that problem and gives us a strong indicator of where the problem's coming from. The next level of automating that monitoring includes automating the response. So this allows you to take appropriate actions in the event of a failure or even an anomaly by automatically executing commands on devices or sending API calls to applications or cloud providers. So you can link in CLI commands like SSH or PowerShell or use APIs like webhooks. So the monitoring system can restart ports, deploy additional containers, retest applications, or even dump real-time diagnosis in response to an issue. Now, some people are uncomfortable with automatically running commands on a system as a response. So what we did in our platform is we allow you to control those commands manually through operator intervention if you prefer. So if you want to add a click to restart server function directly into the web interface of the monitoring system, but you want to limit access to that to just administrators or to just after hours support, there's an easy way to do that. One of our customers even set the system up to restart the server automatically after hours, but only notify the NOC during business hours when they're fully staffed, so that then the operators can make that decision when they're available to do so. One thing to keep in mind, though, is that if you're automating this kind of response, maintenance windows become absolutely critical. Otherwise, a scheduled software upgrade is not going to go like you expect, as the monitoring system is going to take action in the background. Nothing's more frustrating than pausing an application service so that you can do a deployment and then having the server suddenly reboot on you. Fortunately, these kinds of maintenance windows are easy to create via the user interface or the mobile app or even via an API if you want to integrate it into your existing change control process. Now, I'd like to take just a moment to talk about who we are for those of us who haven't worked with us before. Netreo is in the middle of our 20th year, and we've been profitable since year one with a proven track record in both public and private enterprise and a customer retention rate of 98% going all the way back to day one. We've won Monitoring Product of the Year from Network Computing UK 4 years running, and we made it into the Inc. list of fastest growing companies for the last 3 years as well. In 2018, after many successful years of being internally funded and profitable, we did a private equity transaction to gain additional working capital and resources, as well as access to some very experienced business experts, which allows us to grow even faster. So now I'd like to take a few minutes to address any questions that you have. So please feel free to enter those into the GoToWebinar question interface if you haven't already, and we'll make sure to get those answered for you. I'm also going to launch a poll right now that should give you an additional way to contact us. So if you'd like us to reach out with you or follow up, you can use that method to let us know and we'll get in touch with you privately. So the first question is, what kind of APIs are supported for alert actions? That's a great question. So when we're sending out alert actions, we can actually execute commands directly on devices via SSH and PowerShell, like I mentioned, but we can also interact with any kind of webhook or RESTful type API. So we can send information like a JSON payload directly to a ticketing system or to a cloud provider to force an external reboot of a system, for example, that's become non-responsive. You can also use this to integrate with notification systems like Opsgenie or PagerDuty, or directly into a command system like ServiceNow. You've got a lot of flexibility in terms of how those APIs are set up, and the whole process is actually pretty easy to configure and fairly well documented with detailed examples in the knowledge base. The next question is, can I assign a dashboard to a specific user? So what we've done with our tool is essentially all of the different dashboards are fully customizable, including the ones that come out of the box pre-configured for the solution. So you can create new dashboards or edit existing dashboards to make sure that they only include the information that you want to really focus on, and then assign that to a specific user or group of users. So you can say, okay, all of my database users, this is their default dashboard. It focuses only on the database type servers and maybe has some additional information about any current incidents going on with my storage environment that might be affecting them. It's not going to limit their access to those devices unless you specifically configure that, which you can do. But it will give them a way so that when they log into the tool, they're getting kind of the primary dashboard they want. You can also create what we call unauthenticated views. So you can activate views that don't require a login at all to give high level information if you want to run a kiosk in the NOC or an information radiator like a monitor sitting in your middle of your IT section that everybody has to walk past. You can customize a view and then assign that as an unauthenticated view so that the kiosk can stay logged into it, but can't drill into any detailed information from there. Thanks for joining us. Hopefully we've shown you today how we can not only monitor your in-house private cloud and public cloud resources all from a single integrated dashboard, but also give you a view into how our uniquely flexible deployment options, best-in-class data retention, and automated reporting and anomaly detection can help ensure that you've got all the data you need to make the right decisions, no matter where you decide to host your data, your monitoring platform, or your enterprise. If you've got any other questions or you'd like to get some additional information about anything you've seen here, please feel free to reach out to us at info@netreo.com or by contacting your support engineer. Thank you and have a great rest of your day.